So there are a few points in this problem that I would like to highlight just before we move on. One thing is it's a really good idea to remember the closed form expression of the geometric sums. So this stuff over here is just gold. It's a good idea if you just are able to memorize stuff like this. Also the version where it starts in 1, so where it starts in k equal to 1 and goes up to n, a to the k. If you take the sum of that, then it's just another a multiplied onto this expression. So it's like such. It's a really good idea to memorize this because we will be using it again and again. Another point that's quite golden that you can use in the future is if you want to accumulate and discount different payment streams, then you can always do it back until one time point and then gather all of that and then just move it around by using discount factors, as in the sense that we did that when we needed to find the present value 3 months into the year, and then we just said, well, let's just look at it at the value of the payment stream at the half year point, because that's easier because all the payments fall in half years, and then we just discounted another quarter year. So that was the second point. And the third point that can be good to remember is that the discount factor, when you get it annually using the annual interest rate, then you can also just get it half yearly by taking it to the 1/2 power. You can get it thrice a year by taking it to the 1/3 power. You can get the quarter yearly discount factor by taking it to the 1/4 power, and so on. And the reason why you can just do that is partly because of the argumentation in the book on fractionated interest, but also partly if you consider the continuous interest as we talked about in the beginning. Well, then you can actually just see that for the continuous interest, if you assume that interest is accumulated continuously, then it falls very well into sync with the annual interest, in the sense that if we want to accumulate, if we want to discount for 1/2 year and do it using the continuous assumptions, that's just the same as taking the yearly discount factor and lifting it to the 1/2 power. So those three things, geometric sums, that's the first one. So I'll just clear the board here for you guys so we can remember this stuff here. So one is geometric sums, always very useful, and if you can write your present values in the form of a geometric sum, then you're golden. Two is you can, when you're trying to evaluate payment streams, you can discount to time, to one time that's easier, to time t, and then discount to another time point. After you've gathered all the payments. And the third is, well, when you have to discount something, so if I is the annual interest, and you have to discount something for 1/nth of a year, then the 1/nth discount factor. If you want to find the present value of a payment that is paid 1/nth of a year from now, then it's just equal to multiplying by the discount factor to the 1/nth. So remember those three things from this exercise.